One of the common problems that we run into is how to load the material. I mean, it seems silly that you would say, oh, I got to load the material, that's easy. But what happens is, using different techniques, you can indeed get lots of little bubbles inside of here. And the problem with that is the bubbles are very compressible compared to the liquid or the other material that we have in here. So when you do your prime and unprime, we just squeeze the air. We don't actually displace the liquid. So you really want no bubbles in here. Couple different techniques. One of them is where you take a full unit and an empty unit, and you'll put them together with a, I think it's a
double female lure connector.
Double female lure connector, and then you will hold the source and press down lightly while pulling backwards and putting a slight vacuum. And this should load it right up. And basically this is a hydraulic jack in backwards. Now, if you pull some air in there, as this one does indeed have air in here, that's not desired. So what I'm going to do is I'm going to undo this, and I'm going to squirt out until I feel like I'm getting to where there's no more bubbles in here. There, you heard that? Another one. There. Alright, and this will be enough for the experiment we're running anyway, and that looks pretty good. There's a few micro bubbles in there, but no major bubbles. Okay, so this is a 200 micron lure needle, and it's very special in that it's a large bore up till they get to the last 2 millimeters, or the last millimeter, and then they run the 200 micron bore through it. Now, whenever you get your material, we have to first ask ourselves, can I even push through it? So there, I'm pushing, and you see the material is flowing out. That is a 8/1000th of a thick hair that's coming out, and actually, can you see it on my hand? And you know what? Let me put it on some black paper.
Against your blue shirt, probably.
I've got some a black surface here. So, if you see the, look at that. It almost looks like electrospinning the way it's coming out. Almost. Okay.
Close up.
You get the light reflecting it? Here, I'll bring it over where you can get the light on it. Okay, and so while you're there, you'll see there's a pattern right here in the corner. I drew this with a laser, and it goes to ever smaller increments. So it starts off at 1 millimeter and moves down to 100 microns spacing. And so, actually 10 micron spacing, which is why the last little bit looks like a solid line. It's thinner between the lines than the actual width of the laser.
Right.
All right, and we're going to do the same thing with this and see what it looks like.
All right.
All right, so there you go, and wow, let's load it up.
Oh, hang on. We're just getting some good videos here.
They're looking for me?
Oh.
So much Vaseline on my
Oh,
hands.
can you bring that tripod over here?
I'm right here, dude.
Oh. What? Oh, God. Okay. Oh, great. Thanks.
Okay, I'm going to go clean my hand off real quick, so you want to put that on pause probably, and then we're going to get a wafer. Yep, okay. Need a little bit of razzle-dazzle tape.
Vacuum's not hooked up?
No, I don't have the vacuum hooked up.
Okay.
I could do it, but it's real noisy. Let's go back to this guy here. Alright, so we have to set the head height. So I'm actually going to save to file. Go to documents. I'm actually going to go to my documents here. And I'm going to call this Vaseline. High res calibration lines. Okay, and now what we're going to do is we have to set the height of the Okay, so you read this number here, 96.2 microns. And so that becomes my new height for that head. This is not a combo drill, it is, and the diameter on this is only 0.2, so you don't have to fill this in unless you start using like our auto grid stuff.
Okay.
And then it's important to note it, and actually it's important because the next time someone tries to do this,
They want to know the setup.
right, 200 micron, short, stainless, lure tip. Okay, and that's going to set that up, and when we hit the H1 down here, which is where we should go, see the G28, that's zeroing it. We really don't need to do that. We don't need to do this. I don't mind if we home it. We can home it. That's fine with me. And then right here, we're going to do a G54. And then we're going to do a G0. Well, we have to, yeah, we can do a G0. And we're going to go X. We got it right there. Well, this should be... Alright, so right now I have a G0, X0, Y0 and a Z of 0.15. That's got to be negative because it's going to be above the bed right now. So I'm actually going to give myself another one here. Let's see if I have a Z going down. Yeah, there's your Z right there. See that Z? So that Z is 0.15. That should be negative. They should all be negative. Let's look at our parameters. Let's go in minus. Minus 0.15. No, that's positive going down. Yep. Well, let's find out what happens. If you do what I think it did, it overwrote it. Alright, it did. So now I gotta open up this other one. Good. Alright, so that's going to give us 150 microns off the layer height right now. And my 54 was 96.2. Oops, wrong one. Not my 54 is my height, H1. 96.2.
Change up.
The motor wire lengths, you said that those weren't right for the sample you handed me.
You can measure what's installed, and then we will double check it when I get done with what I'm doing.
All right, cool.
Great, thank you. All right, I'm gonna put 0, 0 as the offset on there, so we start right there. And then it's gonna run a G54 and G0, X0, Y0. Control copy. Boom, boom. And this is where you put your H, which is the height of the tool height. And it looks it up from the table. So if you had 8 tools or 5, you put H1, it goes to the first one. H2 goes to the second
So
one.
why isn't this H3 or 4 or whatever?
Because I assigned it here. I told it T1. I did that. I can just as easily go like this. I'll make it T. I'm going to copy this line. And you're right, that's good practice. It's a very good question. It's a very good point. So now instead of T1, is T0 is the 0 offsets. 1, 2, 3, 4. 1, 2, 3, 4. So that's going to be T4. Should be. And this may be very confusing and we may end up changing that back. But here it is H4. There. Now it should use offset from head 4. Got the minus correct, and in this case we're going to go to a plus number, so let's go to 5. Minus 5. Z minus 5, so that's minus 5 millimeters. Alright, and I move it to set the feed rate back, and we're already at G0, X0, that is really redundant. All these G0, Z moves can go away. He's just talking to someone for a minute. He'll be done. We're on Skype.
You see Sergey, I think.
He's ready to go to lunch. He's starving. Get him out of here. Okay, so what I'm going to do is I'm going to move that up. And now this is going to run just like if it was the CNC. So it homes the heads, which is the code I have in there, but I can take that away. And the first head it homes is the Z. You always home your Z first, because if you were down inside of a hole when you canceled a job, you home the other ones, you'll bust off your tool.
Yeah.
It's spinning. We're just going to wait for it to start to give me some little string coming out of here. Sometimes when you load the syringe, you know, it's a little bit larger opening, so it pulls the syringe open ever so slightly. And plus, that was the watchdog kicking in right there. We're starting to flow. Okay, now we got it. See the hair coming out? And so now what I'm going to do is I'm actually going to start the print. This is where that lower clinch valve paste reached dividend.
Yeah.
Because that's not much pressure, and it would keep that under control. Okay, it's gonna, and there it goes. And you see what a beautiful bead's going down? Look at that. It's just gorgeous. When you think that that is less than 10/1000ths of an inch wide, and now I'm making it progressively closer and closer together, and also lower and now it's down to like 15/1000ths of an inch, 10/1000ths of an inch between the lines, so it's becoming a blur. And now we're going to prove that it moves diagonally as repeatably as it does in one axis, because it's easy to do anything in one axis. Is that done?
Okay, let's call this auto scaffold. Well, first we're going to put documents. $150. There we go. All right, now we can take this guy here and delete it, and this guy here and delete it, and this guy here, and we should be able to run it, which is cool. And I love working on wafers because wafers are so flat and they are so easy to clean up. You just need a razor blade.
I have no idea what's going to happen. We're about to find out. Give me a little. No way.